Assalamualaikum and good day, student. So in this video number 10, mass balance for reactive process number 10, we will look on how to do degree of freedom analysis for molecular method, atomic method, and extent of reaction method. Okay. As I mentioned in video number 8, to do degree of freedom analysis for each of the method, it requires a different thing. Okay. So we will go one by one based on the requirement here. Right. So we will do now the degree of freedom analysis for this process using molecular, atomic, and extent of reaction. Okay, you have a process that is ethane, goes into a reactor, dehydrogenation process occur, producing ethylene and hydrogen. 100 mole of ethane goes into the reactor, and the product output, we have hydrogen as 40 mole, and the process wants us to find what is the number of mole of ethylene produced and number of mole of ethane unreacted. Balance here. Okay, so in previous video number 9, where we were doing molecular method, we actually used the same process, same example, and we know that using molecular, we've already solved this question, then this question. Okay, now we go back on how to do degree of freedom analysis. You know, it is very important to do degree of freedom analysis before we tend to solve the question, because degree of freedom analysis it gives us indication whether we can solve the question or not, or probably we left out some information, or we do not label our process correctly. Okay, in order to do degree of freedom analysis for this process, for this question, for molecular, under molecular, it requires number of unknowns plus number of independent chemical reaction. Okay, see here, this is, you must know your number of unknowns, label unknown from your process. Okay, and this will be your unknowns, plus number of independent chemical reaction. So since we have only one chemical reaction, so it becomes 1 here. This is what it means by chemical reaction, minus number of independent molecular species, since if you're using molecular, so your molecular species would be ethane, ethylene, and hydrogen, and no other, number of other equation or relationship or information. So when you have this, plus, plus, minus, minus, then should be your number of degree of freedom here. Right? So let's do this for molecular species. Number of unknowns, we have 2 unknowns. Our unknown is N, C2H4, and also NC2H6, right? Okay, this is our number of unknown. Okay, plus independent chemical reaction, we have 1, right? Chemical reaction. So I'm going to erase this for a while because I don't like this green color, so we use red color because it's not so clear for you guys. Alright, so I'm going to use red. Okay, wait for a second. Okay, so let's follow. Let's do degree of freedom analysis using molecular method. Let's say we want to solve this mass balance in terms this process in terms of molecular species balance. So we have to start with number of degree of freedom of molecular first. Okay, so first one, number of unknowns. So how many unknowns do we have in this process? We have 2 unknowns, right? So that is C2 C2H4 and C2H6, right? Number of unknown there, because we need to find these two. So we have to plus, because it says we have to plus this. One chemical reaction, right? We have to minus then one independent molecular species, number of independent molecular species. So how many species we have in this reaction? 1, 2, 3. So it becomes 3. 3 independent molecular species. And finally, number of other equation. Do we have other information besides this information? No. So it becomes 0. So we do not have to write it down. So for this one becomes 0. So we do not have to write it down. So it becomes 2 plus 1, 3 minus 0 degree of freedom. That's why just now in part 9 we were able to solve this question. Okay, the information, this information and also this information is available in your textbook under section 4.7. So you may look into your textbook section 4.7 to have clear information about this molecular DOF, atomic DOF, and also extent of reaction DOF. So now I would like to show you how we do atomic DOF. Okay, so number of unknowns similar to this, we have two unknowns, same, right? So two unknowns we know. So you know this is the one, and C2H6. Refer to your diagram. Number independent atomic species valence. So in this reaction, how many types of element we have? We have only C and H, right? C, H, and H. So here, number of independent atomic species means 2. Because we only have C and H. Minus number of independent molecular species which is not reactive. We do not have it in this question, so it becomes 0. Minus other equation, it becomes 0 as well because we do not have it. Or if you want to, you may leave it 0 here. So it becomes 2 minus 2 equals to 0. DOF. In part 8, we do not use it in part 8. We do not use it in part 8, but see, if you try to solve this equation using atomic, it is possible because it indicates here 0 degree of freedom. Right? So now let's go to extent of reaction. So these are requirements to do degree of freedom for extent of reaction. So let's do number of unknowns, still similar to unknowns from the process. We have C2H4 and C2H6. And it says plus number of independent reaction plus one reaction, right? Because this process only involves one reaction, one independent reaction. So now it becomes 3 unknowns minus number of reactive species balance. The number of reactive species balance here follows the number of reactive species that we have to use in your extent of reaction. In this case, if you want to do extent of reaction methods, we will use C2H6, C2H4, and hydrogen. So it becomes 3, right? Because we need C2H6. We will do balance for C2H6 in extent reaction and also C2H4 in extent reaction and also hydrogen. So we have 3 for this one. And then minus number of independent non-reactive species. In this case, we do not have it. Non-reactive, we do not have it. And finally, other equations, we also do not have it. Okay, we do not have it. So let's see. 2 plus 1, 3, minus 3, so it becomes 0 degree of freedom. So for this question, it is possible to be solved using extent of reaction as well. So you might want to try this and try to do this by yourself and see whether you can solve it within atomic and also extent of reaction. In part 9, we already solved it in terms of molecular. So For more information about what requirements for DOF for molecular, atomic, and extent of reaction, please read into your textbook chapter 4.7, and under that chapter there will be also some examples of how you use how they perform degree of freedom for molecular, atomic, and extent of reaction using the other example, right? So thank you. See you.